This is my Physics Project 1 over the physics of soccer. It is just a basic terminology slide. It's actually this slide and the next slide, and they just go over some terms that I will be using in my presentation. These are just simple textbook definitions of some of the more popular terms, and they will be further discussed later on into the presentation. Okay, so at this point the game has officially begun, and as you can see I have drawn 3 stick figures, and these stick figures represent one player who is kicking the ball from the center field and starting the game. The black arrows, as I indicated on the slide, represent the velocity, while the red arrows represent the force. So starting with the first stick figure, we can see that his foot has a velocity, and this just represents his foot swinging toward the ball. The ball and the stick figure both have a force of gravity that are working on them and a normal force. In the second stick figure, we can see that the foot still has a velocity as it touches the ball, and now the ball has a velocity due to the foot coming in contact with it. There's now not just a gravitational force and a normal force, but there's also acting on the ball the force of the kick and the force of friction acting against the kick. In the third stick figure, we can see that there is a velocity on the ball, a gravitational force, a normal force, and there's still friction. So let's talk about the momentum. The momentum in the very first stick figure is a very high momentum on his leg. In the second stick figure, we can see that the momentum is now going to be transferred from his leg to the ball. Now let's talk about kinetic energy and potential energy. In the very first stick figure, his leg has a very high kinetic energy because it is moving. However, the ball has no kinetic energy because it is not moving. However, the ball does have a very high potential energy. In the second stick figure, where he is actually making contact with the ball, that energy is being transferred from his kick to the ball. And we can call this the law of conservation of energy, which states that energy cannot be created nor destroyed, it can only be conserved. So, in the third stick figure, we can see that his leg is no longer in contact with the ball, and the energy was indeed transferred to the ball, but his leg is still moving. So through that, we can see that not all of that energy was transferred because his leg is still moving, so there was still some kinetic energy that did not get transferred. As far as acceleration goes, in the first stick figure, the ball is not accelerating. It has an acceleration of 0. But once the foot makes contact with the ball, the acceleration will jump to a very high number and remain constant until contact with the foot is lost. When contact is lost, the acceleration will drop below 0 and remain below 0, which will constantly decrease the velocity of the ball. As far as the motion of the ball is concerned, we could talk about Newton's first law of motion. Newton's first law of motion says that an object at rest will remain at rest, and an object in motion will remain at motion unless outside force is applied. In this case, the object at rest is the ball, and the object that is going to be the outside force is the foot. Once the foot comes in contact with the ball, it will set the ball into motion. So, In this slide, I'm going to be talking about a player who wants to stop the ball. So after the ball is initially kicked to start the game, it's going to be rolling. And as far as this scenario goes, on this slide, I'm going to be discussing how the ball is stopped, but more specifically, the moment right before the ball is at a complete stopping point. So, as the ball is rolling and the player decides that he wants to stop the ball, he's going to leave his heel on the ground and just slightly raise his foot to create an angle where the ball will slide in between his foot and the ground. So, as the ball is rolling into his foot, there is the force of gravity on the ball, as always, and there is also the normal force. The velocity vector is going in the direction in which the ball is rolling, and the force of friction is going against the way that the ball is rolling. So, since the ball is rolling toward his foot, as soon as the ball starts to touch his foot, the friction from the cleat and the friction from the ground will cause the ball to come to a complete stop. Once the ball is stopped, we won't have to worry about the force of friction anymore, or the velocity vector. The only forces acting on the ball will be the force of gravity and the normal force. So, in the last slide, our player stopped the ball, and now he wants to dribble the ball down the field and attempt to score. Now, when we dribble the ball, we don't want to apply force to the ball so huge that it rolls way out in front of us and the other team could steal the ball. We want to keep it controlled. And the way we control dribbling is by giving small kicks. So we will be applying a small force to the ball. As you can see in the first diagram, he is applying a force to the ball, and at this moment, the ball will have a great acceleration, and then after contact is lost, then the acceleration will be negative. In the second diagram, we can see that there is no longer force of the kick, there is just velocity, the force of friction, the normal force, and gravity. So, the way that he keeps the ball completely under control, besides applying small kicks, is to apply those small kicks and make sure that the ball is rolling at a velocity that he can keep up with and that the ball can keep up with. When he applies his kick, the force of friction will play a role and it will slow down the velocity, which is good, otherwise it would keep rolling and get too far ahead. So the key to dribbling the ball down the field is to keep it controlled by small, forceful kicks. So now our player is going to finally shoot the ball and try to score. So the way this works is he will apply a very large force to the ball. And when he applies this force, it will set the ball into motion at a great velocity that will be constantly decreasing. The forces acting on the ball will be the force of the kick, the normal force, the force of friction, and gravity. In the second diagram, you can see that there is no longer the force of the kick being applied. It is just simply the normal force, the frictional force, and the force of gravity acting on the ball. So, he kicked the ball, but unfortunately the goalie was very good at his position and he caught it. So, in this scenario, in the first stick figure, this is the goalie catching the ball. The ball has not actually stopped moving yet. I'm just discussing when the ball is going into his hands and it still has motion. So at this point, the ball has a velocity in the direction of the way that it is moving, which is toward the goalie. And there is gravity, and the normal force acting on the ball would be his hand. There is also the force of friction against the motion or the velocity, and that's the friction of his glove. In the second stick figure, we can see that this is where the ball has completely stopped and is just sitting in his hands. And the only forces acting on the ball are the force of gravity and the normal force, which is applied by his hands. Okay, so our goalie has decided that he wants to punt the ball to his teammates. So he holds the ball out and drops it. And at the point it is dropped, the only force acting on the ball is gravity. While the ball is falling, as we can see in stick figure 1, the goalie begins to swing his leg, which we see in stick figure 2. When contact with the ball is made, there are two forces acting on the ball, and that is the force of gravity and the force of his kick. While his foot is in contact with the ball, the acceleration will jump a highly positive number and remain constant there until the contact with the foot is lost. Once the contact with the foot is lost, the acceleration will drop below 0 to a negative number, which will gradually decrease the velocity. As we can see, when the ball is still in contact with his foot, the velocity will go in the upward direction, and it will be a positive number. The second ball, we can see that the gravity is the only force that is acting on the ball, and the velocity has decreased from the first ball because the acceleration is negative. The third ball, we can see that the only force acting on this is gravity, and that velocity, there is no velocity in the y direction, and there is no acceleration. This is because the ball is at the top of its trajectory. In the first picture of the ball, we can see that there is a gravitational force. There is also air resistance. There is velocity of the ball in the x and y direction. However, there is no acceleration. This is because the ball has reached what we call terminal velocity. In the second figure of the ball, this is just as the ball is hitting the ground. Here, we can see that there is gravity, a normal force, and a velocity of the ball in the x and y direction. In the third figure, we can see that the ball is now rolling on the ground. There is gravity, a normal force, a velocity in the x direction, and friction. Friction will cause the ball to eventually come to a complete stop, which we can see in the fourth figure of the ball, where the only forces acting on it are the gravity and the normal force. Now that the ball is back on the ground, the team will go to the ball, and a player will dribble the ball down the field, as we have discussed previously, while keeping the ball controlled. And then he will stop the ball, as we have also discussed previously, and then he will kick the ball, as previously discussed as well. The goalie will hold out his hands to receive the ball once the player has kicked it, and hopefully he can block the shot and it'll be a tie game. However, due to the immense amount of pressure that is put on the goalie, he's a little nervous and his hands are a little sweaty. And due to his sweaty hands, the coefficient of friction will drop tremendously. So, as the player kicks the ball, in stick figure 1, we can see that this is when the ball is just coming into his hands. So, the ball has been kicked, there is a gravitational force, there is a normal force, there is the velocity of the ball, and there is the friction of his sweaty gloves. However, because of the reduced coefficient of friction, he messes up and the ball slides through his hands. The ball will continue on around or on the other side of the goalie, and its velocity will be in the direction of its motion, like when it was kicked. The only other force acting on the ball will be gravity, and unfortunately, his team loses and the other team will win. This is the physics of soccer.